All right, welcome to class, everybody. I hope that you guys had a good weekend. So our lesson today is section 3.3, which is about finding the equations for lines. So in 3.1, we talked about how lines are used to represent solutions to equations that have two variables, because there's always going to be an infinite number of solutions when you have equations with two variables. So we use lines to represent those solutions. And yesterday we talked about the slopes of lines, and today we're going to talk about how to write the equation of a line. So as a reminder from yesterday's or Friday's class, parallel and perpendicular lines, their slopes have relationships between each other. So like these two lines are parallel, the blue and green ones, and their slopes, if you notice, are the same. They're both -3/5. And then the line that's perpendicular to it is the opposite reciprocal. Because 3/5 is like a small number, which means that the line is going to not be very steep, but the perpendicular line has to be like oppositely as steep. So like, since this is rather shallow, the perpendicular line is pretty steep. And so that's why you do the reciprocal. And then the opposite is just because like this is a negative slope versus this is a positive one. So we talked about that last class. And the formulas you guys are going to need for this class are the slope-intercept form of a line, point slope form, and standard form. So these two are definitely the most useful, and I really don't like standard form. But your homework has some of these problems in it, so I'll explain how to use this form. But really, these two are the most useful. So slope-intercept form, you've probably seen before. It's y equals mx plus b. And so when you write an equation with this, you're going to have whatever slope number you have for the line, that goes in the m spot, and whatever the y-intercept is, that goes in this spot. So that's slope-intercept form. And then point slope form, same thing, and it's still representing the slope, but you're going to have two numbers, and these two numbers are going to be a point on the line. So that's point slope form. And their names basically reflect what information you need to be able to write the equation. So for slope-intercept form, you need a slope and an intercept. For point slope form, you need a point and a slope. And then standard form, the A, B, and C don't represent anything in the equation. It's just kind of a way of arranging the equation. So you want to have the X and the Y on the same side of the equation. And you want to have the numbers that go with all of these terms to not be fractions. So they need to be whole numbers. And the whole number that goes with X needs to be positive. So again, I don't really like standard form too much because the letters themselves don't mean anything. You could use some combination of the letters to find things, like, for example, the slope of the line is going to be -a/b. Or you could have like the y-intercept is going to be c/b. Like if you do combinations of these letters, then those will represent things, but the letters themselves won't represent anything on the line. So I don't really like using standard form in general. But if you're ever asked to put something in standard form, you basically just put it into one of these two forms and then you convert it until it looks like this. So for example, you might have like an equation like y equals 3/2 x plus 5 or something like that. If you were asked to put the equation of that line into standard form, then you would multiply everything by 2 because you can't have fractions when it's in standard form. So you would get 2y equals 3x plus 10. And then you would want the x and the y on the same side of the equation, and you want the x number to be positive. So I would keep x on this side and subtract 2y from both sides, as well as subtracting 10 to move the 10 over. So that cancels out, and you get -10 equals 3x minus 2y. And that would be the standard form version of this equation. So if you were to graph these in a graphing calculator, they would both be the exact same line. It's just different forms of expressing it. Do you guys have any questions on that? Okay. Same thing with point slope form. A lot of times they'll give you a problem where you need to use point slope form to find the equation, but they might ask for it in slope intercept form. So you might end up with an equation that looks something like y minus 1 equals, I don't know, 3 times x minus 5. So that would be in point slope form because it's matching this form. But if the question asked you to give your answer in slope intercept form, then you would want to get the y by itself so that it looks more like this. So you'd get rid of the parentheses first, which would give you y minus 1 equals 3x minus 15. Then you'd add 1 to both sides and you get y equals 3x minus 14. And that would be the slope intercept form of this same line. So any line can be represented in any of the forms. You just kind of choose the form that ends up being the most useful. And in general, standard form is never going to be useful. So you'll basically just choose between those two. But sometimes they'll ask for the answer in standard form, so you'll have to convert it to that. Any questions on the formulas or anything? Okay, then let's go into a couple of examples. Well, actually, sorry, first, I want to show you guys really quick where these formulas come from, because it's actually connected to something we've already learned. And you don't have to like know this for a test or anything, but this is just, it might be helpful for like memorizing the equations. So you know how like last class we talked about how the slope equation can be calculated as subtracting the y coordinates and subtracting the x coordinates of points? That was something we talked about in last class's lesson. So essentially the point slope form is, instead of having numbers here, you're just going to put in variables. So rather than having a y coordinate that's a number, you just put a general y coordinate. That's going to be one of your variables in the equation. And then you put a general x in this one. And then you multiply both sides by the denominator so that you don't have a fraction. And so that gives you m times the denominator equals the stuff that was on the top. So point slope form is essentially a rearrangement of the slope equation, where instead of having numbers for both of your coordinates, you put in general variables for one of your coordinates. Does that kind of make sense? And then slope intercept form is basically a special case of point slope form, because the intercept or the y-intercept is always going to be where x equals 0. And so the y-intercept is actually a point itself. And if you plug that into the point slope form, you'd get y minus b equals m times x minus 0. And if you rearrange that equation, well, x minus 0 is just x. M times x is mx. So you get y minus b equals mx. Then if you add b to the other side, you get y equals mx plus b. So this is just a special case of this where x is 0. So that's where those equations come from. So on your homework, you're going to have a variety of questions that ask different things. So on some of them, you might be given an equation like this, and you're asked to find what's the slope, what's the y-intercept. And so the way you would do that is you would just look at the equation, and since this is in slope-intercept form, and the number that's multiplied by the x is the slope in slope-intercept form, and the number that's added onto the end is the intercept, then that means that our slope in this case would be -2, and the y-intercept would be at x is 0, y is 4. And then we could graph the equation. So the y-intercept is a really good place to start because we know that that's going to be on the line. So we could graph that point. And then you could say like, okay, well, what if x was 1? Well, -2 times 1 would be -2 plus 4 means that y would have to equal 2. And so this point would have to be a solution to that equation. And then you could just graph the line. Another way, though, that you could do this as well is you could write your slope as a fraction and do rise over run from your y-intercept. So you could go down 2 and over 1, and that would be another way to get that same point. So you can kind of do it whichever way makes the most sense for you. But basically, to graph it, you get 2 solutions for your equation. And then if you're asked to find a parallel line, the main thing you just remember with that is that parallel lines have to have the same slope. So you could say my parallel line could be y equals -2x. And it actually wouldn't matter what y-intercept you did, because like I could do a parallel line that looks like this, or like this, or like this. And like, regardless of where I put the y-intercept, it'd still be parallel. So you could choose any random y-intercept, unless the problem said specifically, like find a line that's parallel that goes through this point, in which case you would use that point as your y-intercept. And then a perpendicular line would be the same idea. You would do y equals, instead of having the same slope, you'd have the opposite reciprocal slope. So you do like 1/2 x and then whatever y-intercept you wanted to do. Do you guys have any questions on that? Okay. On this idea of parallel and perpendicular, I want to do or show you guys one question. So I think this is this one's question 6, and I think it's 5 or 7 that's similar to this. On these ones, they're not asking for the equation of a parallel or perpendicular line. They're asking for just the slope of parallel and perpendicular lines. So in this case, you're not going to write out a whole equation like y equals slope times x plus the y-intercept. You're just going to write what the slope needs to be and what the slope needs to be here. Although let's actually go ahead and do this one, because in this one, it's not in slope intercept form to start with. So this is in standard form. Well, actually, it's not technically standard form because the number of the x should be positive. But in any case, it's not in slope intercept form. And so in order to solve this problem and find the slope, we would need to get it into a form where we can interpret the slope from it. So I think the easiest one to get it into would be slope intercept form, which is the one where y is by itself. So essentially, I'm going to solve this equation for y. So if I want to get y by itself, I have multiplication by a -5, and then I have this -5x that's being subtracted or added to the -5y. So to get rid of that, I'm going to add 5x to both sides. And that gives me -5y equals 5x plus 5. But y still isn't by itself, so I need to divide by the -5. And that gives me y equals, and when I divide 5x by -5, I get -1x. And when I do 5 divided by -5, I get -1. And so this equation would graph the same line as this one, but it's in a form where it's easy for me to find the slope of it. So this is the line they gave me, and they want to know what the slope of a parallel line should be. Well, the slope of a parallel line should be the same slope. So you would say the parallel line needs to have a slope of -1. And then if you want to do a perpendicular one, you do the opposite reciprocal. And what's the reciprocal of 1? Yeah, just 1. So this would be +1 because it's the opposite reciprocal of the same slope. So sometimes if they give you the equation in standard form, you'll have to convert it to one of the other forms to be able to find the slope. Let's see. So that's basically what I was going to do with this problem. So I'll skip that one. On this one, if you're asked to write the equation of a line, in general, you want to look at what they're giving you and decide which of the two forms is going to be the most useful. So like in this case, since they gave us a slope and they gave us a point, that means we would use point slope form because we have all the information we need for that. So we would write that as y minus 2 equals the slope times x minus 4. And that would be the equation in point slope form. If they said write the equation of a line and they specified that it had to be in like standard form or slope intercept form, then you would manipulate this equation until it looks like the form you want it to. So like if you wanted to get it into slope intercept form, you would get rid of parentheses and you'd get y minus 2. Say it again. Close. It'd be plus 12, yeah. Because you gotta distribute this, and then you would add the 12 or add the 2 to both sides after you get rid of parentheses. Nope, you're totally good. So then we'll add 2 to both sides, and we get y equals -3x plus 14. So again, this equation and this equation graph the same line. They're both equations of the exact same line. They're just in different forms. So on your homework, pay attention to what form they're asking for. And then if they had asked for standard form, you would kind of go through all the same steps, but you would add 3x over to this side. So the x and y would be on the same side. So let's see. So we've got that one. On this one, we have the slope is 1/2 and the line crosses the y-axis at 4. So in that case, which form of the equation would you use to start? Yep, slope-intercept form, because they gave you a slope, and when they told you it crosses the y-axis at 4, they gave you the intercept. So you could use y equals mx plus b and plug in your slope and your y-intercept, and that would be your equation. And if you wanted to get this one into standard form, you would multiply by 2 to get rid of the fractions, subtract the y, and subtract the 4 to get the x and y on the same side. But again, I think standard form is dumb. The only reason I'm even telling you about it is because there are some problems on your homework that ask for it in standard form. Yeah.
On any test, will like in the class, will we be asked to do it in like a certain form, or is it whatever?
Usually, so on the tests that I write, like not your homework tests, but like the actual tests, I'll usually ask you to put it into slope-intercept form. Because with point slope form, like there's a million of tons and tons of points on the line. And so like you could get multiple versions of the same line, but it would have different numbers in it. So I'll usually ask you to put into slope-intercept form. Yeah. And like I may give it to you in standard form and then ask like, what's the slope of this line? And so you need to know how to get it out of standard form into a form where you could find the slope. Any other questions? Okay, last one I want to show you guys before we move on to the homework is if you're asked to find the equation of a line that passes through 2 points, the only information they gave us here is the 2 points. And so in order to write an equation for a line, if you think about our 2 options, we can either do slope-intercept or point slope. But in both cases, you have to know the slope. And in this case, they didn't give us the slope, but we could figure out the slope because we have 2 points on the line and we can figure out how steep it is between those 2 points. So I could graph the 2 points and I could say, well, one of my points is 3, 1. One of them is 8, 4. And the rise between those 2 points is +3 and the run is +5. And so I would say my slope is 3/5. And you could have also figured that out by doing 4 minus 1 would give you 3 over 8 minus 3 gives you 5 if you like doing formulas more. But if they give you 2 points without any slope, you kind of have to use those 2 points to find the slope. And then once you've got the slope, if one of the points is a y-intercept, you could use slope-intercept form. In this case, they wouldn't be, so you would just do point slope form. And you could actually choose either point. So you could set it up as y minus 1 equals 3/5 times x minus 3. Or the other possibility is you could do y minus 4 equals 3/5 times x minus 8. And both of those would be correct. They're both in point slope form. They're both describing the same line, but it's a little bit easier to see that they're talking about the same thing if you get it into slope-intercept form. So like I could get rid of the parentheses, which gives me y minus 1 equals 3/5 x minus 9/5. If I add 1 to both sides, 1 can be thought of as 5/5. So if I do -9/5 plus 5/5, that's going to be -4/5. So this would be the slope-intercept form of this equation. And then you could do the same thing if you did this other version that we did. And that would be y minus 4 equals 3/5 x minus 24/5. If I add 4 to both sides, 4 is 20/5. So -24 plus 20/5 would be y equals 3/5 x minus 4/5. And you can see when they're put into slope-intercept form, you can see more easily that they're the same equation. So that's how you would do one of those. But just when you're like going through your homework, just notice what they're asked, like what form they want the answer in, because it varies depending on the question. So that's everything I wanted to go over to start with. So you guys can go ahead and open up your laptops, and here's a summary of everything we talked about so far. And then I have a couple questions picked out that I think might be helpful for you guys. So I'll start on those once you guys open up your laptop. The first one I'm going to go over is question 10, if you want to follow along. Okay, so on question 10, it says the slope and 1 point on the line are given. Find the equation of the line in slope-intercept form of this line that they gave us the point and the slope for. So even though they want me to give my answer in slope-intercept form, that doesn't necessarily mean I'm going to use slope-intercept form, because the form that I want to put it in is the one that works with the stuff they gave me. So since they gave me a point and a slope, I'm going to use point slope form to get started, and then I'll convert that form into slope-intercept form. So point slope form says that you do y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. So in this case, since my y coordinate is a -5, I'm going to have y minus -5, which is the same thing as y plus 5. That's going to equal my slope of 2 times x minus the x coordinate, which is 1. And so I'm going to have that as my equation. And that is a totally valid equation of a line. You could plug that in a graphing calculator and it would graph a line that had a slope of 2 and goes through the point 1, -5. But it's not the answer I'm going to type in, because they asked me to write the equation of the line in slope-intercept form, which means I have no parentheses and the y is by itself. So I'm going to convert this to slope-intercept form by distributing the 2 to get rid of parentheses. And that gives me 2x minus 2 on the right-hand side. And then I'll subtract 5 to get the y by itself. So I end up with y equals 2x minus 7. And this is the same line, but an equation in a different form. And so that would be what I would type into this problem here. So that would be question 10. Do you guys have any questions on that so far? Okay, maybe I'll give you guys like a minute or so to finish that one up if you're also working on number 10, because you might have different numbers than me. All right, the next one I'm going to go over is question 16. So on question 16, and I know from my last class that like other people have like different structures for this one. So if you have something that's different than this one, let me know and I'm happy to work through your example. But on my example, it says find the equation of a line that's parallel. So I'm looking for a line parallel to the graph of this equation. And I want it specifically to be a line that contains the point 0,3. And so in order to solve this one, I need to think about, well, which form is going to be easiest? Do I have a point and a slope, or do I have an intercept and a slope? Point slope. And actually this point ends up being an intercept, because it's like if x is 0, that's where the y-intercept is. So you could actually use either form. So either one would work. However, it's not super easy to see what the slope is in this equation, because the equation they gave me is kind of in standard form. The x shouldn't be negative if it was standard form, but like it's not easy to tell what the slope is from that. So I'm going to rearrange that equation they gave me to figure out what the slope needs to be. because I can't just tell from it directly what it should be. So I'm going to get the y by itself by adding 4x to both sides, which gives me 3y equals 4x minus 1. And I'm going to divide both sides by 3, which gives me y equals 4/3 x minus 1/3. So if I were to graph this equation, I would have a y-intercept at negative 1/3, and then I would have a slope of 4/3, which would look kind of like this-ish. So this is the line they gave me, but they want me to find a line that's parallel to that line that goes through the point 0, 3. So what they're asking for is essentially this line right here. And so since I know what the intercept is, I could just go straight to slope intercept form, but you could also use point slope form if you wanted to. But in this case, my slope has to be the same slope as the slope of the line they gave me, which is 4/3. And then the y-intercept would be a positive 3. So this would be my equation. If I had chosen to do a point slope form, you would still get the same answer, because point slope form would be y minus 3 equals 4/3 times x minus 0. But when you simplify that and get y by itself, you end up with y minus 3 equals 4/3 times x, because x minus 0 is just x. And then you'd add the 3 over, and you end up with that same answer. So in this case, because the point they gave us was the y-intercept, you can just go directly to that. But even if it wasn't, you could still use point slope form to get to it. Yeah. Yeah, so point slope form will work for any point. And like, so if it hadn't been a 0, like let's say it was like 3, 5 or something, then you would have a 5 here and you distribute the fractions to both parts. So the only thing that makes it easier if you have a intercept is the fact that you get x minus 0, which means that this parenthesis stuff just becomes an x. And so. Did anyone have another version of 16 that you're not sure how to answer from what I did? Because I know some of them had like different types of points and things. Yeah. Okay, so you had the point 4, -4, and was it asking for a line parallel? Yeah. Okay, so parallel. And what was the equation of the line it's parallel to? Like that? Okay, awesome. So the first part is going to be very similar to what I did, because in order for the line to be parallel to this line, it needs to have the same slope. But with that equation, you can't tell what the slope is. So you want to get y by itself so that it's in slope intercept form. So I'll add 2x to both sides. And that gives 4y equals 2x minus 1. Divide both sides by 4. You'd get y equals 2/4 x, but you could write that as 1/2 because 2/4 reduces. And then -1 divided by 4 is -1/4. So this is the slope intercept equation for the equation they gave you. But it's not the equation we're looking for, because we want a line that's parallel to that, but goes through the points. And so you would say, okay, well, since I have a point and I know that my slope needs to be the same as the slope of the line they gave me, then I'll use point slope form because I have a point and I know what the slope is. So I'll just write down that I know that the slope has to be 1/2. And like, if I don't think there's any problems on your homework, but if it had said like, write the equation of a line that's perpendicular to the line, then like you would just say that the slope needs to be -2 because that's the opposite reciprocal. But in this case, since it's parallel, we're going to use the same slope. So then you would set it up and you would say, okay, well, y minus the y coordinate is y minus -4. But if you minus -4, that's the same thing as adding 4. And that needs to equal 1/2 times x minus the x coordinate, which is 4. And actually, you don't have to have these parentheses, but you can write them if you need to. So then from here, does it say on your 16 what form they want it in? Slope intercept. So to do that, we need to get y by itself. So first of all, I'll get rid of the parentheses because slope intercept form also doesn't have parentheses. And 1/2 times -4 is -2, I think. And so we get y plus 4 equals that. Subtract 4 from both sides, and you get y equals 1/2 x minus 6. And that would be the slope intercept form of it. Uh-huh. Yep. Yeah. Which one is it?
Oh, I'm sorry.
On 16?
No.
That's totally fine. Yeah, which number is it? Number 11. Okay, does yours look like this or do you have other numbers? Oh yeah, that's very different. Okay. I have one like that that is on this one. So your numbers are -2, -5, and -1, -1. Okay. All right, so in this one, what information were you given? Perfect. And are there any equations of lines that have 2 points as like what you need? So we have slope intercept and point slope. Yeah, so we can do point slope, but we also have to know what the slope is before we could use it. So we can find the slope between the 2 points, either by doing, yep, exactly. So maybe I'll do it with a formula, but you could also graph it and like look on the graph. Yeah. Okay, so I did it, I got 4/1. So just 4, is that what you got as well? Okay, awesome. So now that we know the slope, and we actually have 2 points to choose from, so we can use point slope because we have a point and we have a slope. And you can choose whichever point you think is easiest, because we had to have 2 points to find the slope, but for point slope form, you only need a single point. So it doesn't matter which one you choose. Do you have a preference?
Yeah.
Okay, awesome. So we'll do y minus -1, which is y plus 1. And then 4 times x minus -1, which is plus 1. And so we end up with that. And then they want the answer in standard form, which means that we need to not have any parentheses. So I'll get y plus 1 equals 4x plus 4. And then the x and y need to be on the same side of the equation, and the x number has to be positive. And for standard form, yeah. Yeah, because standard form looks like this. Oh, well, my thing's in the way.
Yeah.
But it looks like that, where A, B, and C are all whole numbers. And then I forgot to write this down, but A also has to be positive. Yeah, that's one of the qualifications of standard form. And so if we come back here, yeah, because you subtract it to get rid of it. So like in this case, we're going to subtract y because we want the 4 to stay a positive because that's the number with the x. So we're going to subtract y over, and then everything else we want to get to the other side. So I'm going to subtract 4 because that will cancel out this. Yeah, so B and C can both be negative, but A has to be positive. And that's just like one of the formatting things of how standard form works. Yeah. Okay. Okay, give me just a second to finish this one up and then I'll help you with that. Yeah, so this is what I got for your final answer.
That's what I got.
Awesome, cool.
So then it wouldn't matter how I read it in the.
I mean, probably it wouldn't, but technically standard form like usually has the X and Y on the left side. So you would write it kind of like that.
Let me see what-
But I would imagine it should accept it either way. Yeah. Okay, what was your question on?
So mine has a coordinate, not the y-intercept.
And you said it was question 10?
Yeah, I'm looking for an intercept, but when I graph it out, it's like a fraction of decimal. Instead of being a straight answer.
Okay, so yours is like, it looks kind of like this, but you have different numbers?
Yeah.
Okay. So let me get what your numbers are. So what was your slope? -3, okay, and your point?
5, x is 5, and y is 4.
Like that? Okay, so if you graphed it, I think you're right that like the slope wouldn't end up, or the y-intercept wouldn't end up being a whole number. Cause you could go like down 3 and over 1. Or you could also go like up 3 and backwards 1. And like if you kept on doing that, like you would eventually see about where it's going to hit the y-axis. But it's not a super effective way to find out what the y-axis number should be. So a better way to do it would use point slope form. Because you could say that y minus 4 equals -3 times x minus 5. That's the point slope formula.
Forward negative.
Then it would be plus. Because if you minus a -4, that's the same thing as adding 4. And then to get it into slope intercept form, then you would distribute and you get -3x plus 15 equals y minus 4. And then to get the y by itself, add 4 to both sides. And oh, I guess it would end up being a whole, yeah. So the y-intercept would actually be 19. Mhm. Sorry, I have like a whole bunch of questions. First of all, does that answer your question on how to do that? Okay, awesome, go ahead.
Number 10.
Okay.
Number 10. So my number 10. My number 10, that was the
Mhm.
question,
Mm-hmm,
and that was how I solved it. Right?
mm-hmm. That looks right to me.
And then that's what.
-2. Oh, when you distributed the -2, you didn't keep the negative with the x. So this should be a +6, but if you change it to a -2, that should fix it.
I see.
Yeah. Okay, what was your question on? 15? Oops. Oh, so you probably have a different line than mine.
Yeah, and I tried doing this 3 times.
Okay. It's probably a standard form. So how did you solve it?
Oh, well, this is the third.
Okay.
So it's 0 and -4. is
Mhm.
1,
Mhm.
And then 0 and 5.
Mhm.
So you can do the,
Oh, so this one would actually be -4, 0, because the -4 is on the x-axis. So those two numbers would be switched. That might fix the rest of it
yeah.
potentially. Let me know if it doesn't work.
I'll raise my hand.
Okay. Oh. Yeah.
It's my number 13 question.
Yeah.
So it's asking
This one might be helpful for everybody. So let me just copy down your numbers. Which number is this?
So I have this, 2.
What problem number?
Oh, it's number 13. Sorry,
Okay.
I mentioned that.
No problem.
So 13, and then it's 2, -5, and then 0, 2. And this needs to be a standard form.
Standard.
And I try to get the slope, and then I try to put the, I guess, the point slope. Go to the standard. It's not saying that's correct.
Okay.
Don't know what I did wrong.
Okay.
Because I didn't put it, did the with those points. And yeah, then it's,
Okay, so I mean, I could look through your work really quick.
yeah, like, so
So you found the slope was,
should be 7, -7 2,
is it positive or negative?
negative.
Okay, yeah, because if you go from -5,
So it's 5 plus 2 plus 5 should be 7, 0 minus 2 should be -2, right?
uh-huh. Yep, okay, so then we did that. We got that,
So try that one first because of 9.
and then you add the 2. Or, yeah, that's good, put that over there, add the 2. Okay, so this is almost in standard form, the only thing is that you can't have fractions. So just multiply everything by 2, and you'll get like 7x plus 2y equals 4, and that should be your standard form. Yeah. That should fix it. All right, did that one not work?
I'm just afraid, so
Oh.
I got 5/4, right? X.
Yep. Mm-hmm.
And I minus it because it's standard form.
So you want the x number to be positive. So since it's already positive, you want to keep it on that side and move the y to the other side. You also want to get rid of the fractions. So I would do the fractions first. So like write it as like multiply everything by 4, which would give you 4y equals 5x minus 20, I think, or plus 20. Yep.
So minus 4y.
Mm-hmm. Yeah, from both sides. Yeah. Yeah, and that should work. So the one that you end up subtracting or getting rid of depends on what's going to make x positive. So if x is already positive, you let it stay on that side. And then if it's negative, then you just add it to the side that has y.
Oh, yeah.
And that's just like one of the quirks of standard form. Well, I guess I shouldn't say quirks. It's one of the like things that makes it standard form. Yeah, what was your question number? Number 5. Okay, and what was the equation of your line?
So is that 3 and a third?
Yeah.
So then plus 4, that'd be 7.
Y equals 2x. Because that's what I was
7.
Yeah,
Oh, that's gonna be-
so in this, for the line they gave you, what's the slope? 2. So the slope of the line they gave you is 2. So if you want a line that's parallel to it, what does the slope have to be? Yeah, so, and they only asked for the slope of the line. They didn't ask for the equation of the line. So you literally just say it has to be 2. And then this one would be -1/2. Yeah. Mhm. Any other questions you want help with? Yeah.
Okay, so the answer to this one is +7 1/3, but like it's not letting me type it in like that, and it's not letting me type it in like 8/3.
And they want it in form. Yeah, so it should be 8. They should allow 8/3.
I keep.
Okay.
And it's like,
So
am I doing
let's-
the math wrong on it?
Possibly, let's see. So you. So the slope is going to be -5/3. And then confuse that one. 2. So 5/3, -5/3 times -2 would be +10/3. So I would,
So 10/3 +4, so it'd be 14/3.
so no, because 10/3, if you add 4, you have to have common denominators, like you have to be adding thirds to thirds. So if you have 10/3, 4 in thirds, I think is 12/3. And so you'd have 10/3 plus 12/3, which would be 22/3. So it should be 22/3.
That's very
Which
confusing.
actually, sorry, I
Oh,
don't know
yeah,
why I
that
didn't
was-
catch this at the beginning. This is still actually 22/3 because 7 is 21/3.
Oh,
And then plus one.
Oh,
Yeah.
okay, that makes sense.
Yeah,
Okay,
so
thank
sorry,
you.
I didn't catch that earlier. That is the
I
correct
just-
answer, but yeah,
Yeah,
it,
it's the same. How I kept typing it in. It's not working. But thank you.
uh-huh. Did you have a question?
Oh, no,
Okay.
no, yeah.
I saw like your hand go up in the
Oh,
back
it
of
was
my.
the-
All right, which one is your question?
For the 2 points,
Oh.
if I have the 2 points,
Mhm.
can I convert them or not?
Convert them into
Like
what?
into whole numbers?
Not the points themselves, no.
Okay,
You will be able to do it once you get an equation, but you can only,
all right. So
get
it's
rid
like,
of-
how do I work with the?
yeah, which number is that?
It's 13.
13,
No, it's 14.
14. Okay. Let me make a new slide and I'll just do it with your numbers.
Okay.
So you have the 2
Negative
points.
2/3 and 3/5. And then -3 and -4/5.
And this is
To go into
standard
standard
form. You said this is question 14, right?
Mhm.
If you guys haven't finished 14 already, 14 involves fractions, and I'm gonna go through an example with it. So if you'd like to, you can work along with me. So on question 14, you're given 2 points, but the points have fractional measurements. And then you're asked to find the equation of a line and write your answer in standard form. So to be able to solve this, we first of all need a slope, because right now we are only given points. And so we need to find a slope. And this is something that would be really hard to graph and figure out from the graph what the slope would be, because all of your measurements are in fractions. So in this case, I would highly recommend using the formula for slope, which is that you take your y coordinates, so -4/5, and then subtract the other y coordinate over the x coordinates, -3 minus 2/3. Well, actually minus -2/3, so it should be a plus 2/3. And then in order to subtract fractions, you have to have common denominators. And we have common denominators on the top, so we would end up with -7/5. But on the bottom, we have a whole number and a fraction. So I need to write the whole number so it has the same denominator. So in this case, that would be -9/3 plus 2/3. And then this is going to be -7/5 over -7/3, like that. And then whenever you divide fractions, you can think about them as multiplying the reciprocal. So you could think about this as being -7/5 times -3/7, because that's the rule for dividing fractions. And in this case, the 7 divided by 7 cancels out. -1 times -3 is +3, and 5 times 1 is 5. And so the slope in this case would be 3/5. Some of you guys may have like different denominators, like maybe you might have like a 2 and a 3 or something like that. If that's the case, then you would want to find common denominators of like a 6 and then rewrite it before you add them together. So finding the slope is rather complicated because you have to kind of remember all of your fraction rules. Once you have your slope, then you can choose either one of your points. So I'm going to choose the one that only has 1 fraction instead of 2. And I'm going to use that point and my slope that I just found in order to find the equation. So I have a point and a slope, so I'll use point slope form. And I'll do y minus the y coordinate of the point. So I'm going to use this point because I like it, I like that it only has 1 fraction. So I'll do y minus -4/5, which ends up being y plus 4/5, equals the slope times x minus -3, which is x plus 3. And so they want the answer in standard form. So I'm going to get rid of my parentheses first by distributing the 3/5, which gives me 3/5 x plus 9/5. And then standard form is the one where x and y are on the same side of the equation. The number that goes with x is positive and there are no fractions. So I would probably at this point get rid of the fractions by multiplying everything in the equation by 5. And that gives me 5y plus 4 equals 3x plus 9. And the number that's with the x, or the coefficient of x, is already positive, so I want to keep it that way. But x and y need to be on the same side. So I'm going to subtract 5y from both sides, and I'm also going to subtract 9 to get everything else moved, all of the constants moved to the other side. And so when I do that, these cancel out, and I end up with 3x minus 5y, and that equals 4 minus 9, which is negative 5. And so this would be my standard form equation of the line that they gave me. And you could have gone through the whole thing and chosen the other point as well. I just happened to choose the second point because I like that it had a whole number in it.
So in my problem, I have like one fraction within all the points.
Okay, do you want to tell me what your points are?
So I have 3, 1/5. So
Like that? Mm-hmm.
and 1 negative 1.
Okay, so it looks like that.
Mhm.
So you would start off by finding your slope, same thing as on the last one. So you might do this as -1 minus 1/5 over 1 minus 3, or you could do it vice versa. Just make sure you, whichever one you choose to do first, do that. So to do the top part, -1 can be written as -5/5 minus 1/5. And then on the bottom, you can just simplify that straight to -2. And on the top, you'll have -6/5, and then that's divided by 2. But you could write that as -6/5 times 1/2, because that's the reciprocal of 2. And that ends up giving you -6/10, which, oh, actually, sorry, that should be negative, which actually means you'll have a +6/10. And that can be reduced to 3/5. So your slope would be 3/5. And then once you're done with that, or like once you have the slope, then you just do point slope form. And I would probably choose the point that doesn't have fractions. Yeah. Oh, sorry, guys, I went a little overtime, but thank you guys for class. And for those of you that are still here, tomorrow is homework day. So if you show up, my TA will be here to help you guys with homework, but our next lesson will be on Wednesday.